This conference will now be recorded.
So in last session, we created a EKS Kubernetes cluster, and we were able to deploy the application in that cluster. And also, we able to create a load balancer service in that EKS cluster. If you see, we created a client machine. We created a Kubernetes client machine. From this machine, we are able to communicate with that cluster, EKS cluster. Let me SSH to that machine. If you see, we have two machines as part of that, and we deployed some application. If you see, we were able to create a service of type load balancer. External load balancer got created in the AWS ELB. So ELB got created here, external load balancer, this one. This is pointing to the worker machines, that Kubernetes nodes. And the load balancer is forwarding the traffic on this port, this node IP, this node IPs, Kubernetes node IPs, and a node port. When we access using this one, request is going to the load balancer. Now, before I go for an ingress, I want to talk to you about cluster autoscaler. Cluster autoscaler. What is pod autoscaler, guys? In AWS? Yes, sorry, in Kubernetes. What is pod autoscaler in Kubernetes? What is pod autoscaler? To increase or decrease the replicas automatically based on the load, we can create a pod autoscaler. Okay. So we can decrease the pods based on the load automatically. What if the cluster itself doesn't have any CPU, any memory? Will I get another pod automatically even though it's a EKS cluster, unless until we have a cluster autoscaler deployed? Now let me practically show that. I have two nodes as of now. I have two nodes currently. What is the capacity of each node? If you remember, when I created each node, 2 CPU and 8 GB RAM. So then what is my current capacity? What is my cluster current capacity? Total cluster, 4 CPU, 16 GB RAM. Now, let me take something like this. I am trying to deploy one application. I am trying to deploy this Java web app. Even though it doesn't take that much, I am requesting resources. I am going to request resources, maybe half CPU or maybe 2 GB RAM minimum, the resource request. So in that case, how many pods maximum I can create if I request this much? Each pod I am requesting this much. Maximum how many pods I can create? Because I have 4 CPUs. For each pod I am requesting half CPU. Maybe less than 8 also. Not exactly 8 because you have some other pods, Kubernetes internal pods also running, right? In this kube system namespace, you have some internal parts also running. So this might be also reserving some CPU and memory. It may be 8 or it might be less than 8 also. Now, if I create with the resource request that much, will I able to schedule other parts more than like any other parts? Will I get a node automatically in this case? Let me show that. Now I'm updating this one. Yeah, I already have a half core requested and 1 GB memory. Now let me scale manually, right? It can be horizontal, it can be scaled using pod auto scaler, or I can scale manually. Now let me schedule, let me give 8 replicas. Now I deployed with 8 replicas. We have only 2 nodes as of now. Now why there are 2 parts which are in pending state? What could be the reason? How can I check? Whether you are scaling manually, whether pod auto scaler is trying to scale, that doesn't matter. I have some parts which are in pending state. What could be the reason? How can I check? If you see, right, only these many are running. kubectl describe pod. What it is saying? Why this pod is failed to schedule? This pod is failed to schedule because of lack of resources, right? Insufficient CPU. So I'm requesting how much CPU? Resource request. In the pod manifest, we have defined resource request. Half core, 500 millicore. So I have these many parts, but it doesn't mean it is actually taking that much. It doesn't mean this is actually taking that much. The current load might be very less. The current load, you don't have that much load, but it is reserved. Is it allowing you to schedule other parts because of insufficient CPU? No. Now, if you remember, while creating this EKS cluster, while creating EKS cluster node group, I have mentioned, defined something minimum 2, maximum. I told, I think 4 or 5. I think I remember, I think 5. Then why I am not getting third one automatically? Will it create automatically the third one? So what is required here? How come AWS knows? How come AWS knows it has to scale to third one? It has to scale to fourth one. Is there any application or is there any code which will update the EKS, that auto scaling group design numbers based on this as of now? Is anyone is updating AWS saying that the desired number, instead of 2 servers, now I need a 3 servers, or instead of 3 I need a 4 servers? Is there any code application by default which will update the Kubernetes, AWS auto scaling groups? No. So if you see in the background, AWS, that node group is nothing but one auto scaling group. That node group is nothing but one auto scaling group. This one. So currently 2, desired 2. If someone programmatically updates this desired number, instead of 2, it says desired is 3. Then will the AWS auto scaling will provision one more server in the background? If programmatically someone updates this desired capacity from 2 to 3, will the AWS auto scaling will create a one more server to match the desired number? Yes. If someone updates the desired capacity. Now who does that manual? Who does that automatically? That is what node autoscaler does. So the node autoscaler will act as a bridge between your Kubernetes control plane and AWS. So this node autoscaler is one application which will be running in your cluster, which will be deployed as one pod in the cluster. That node autoscaler will communicate with API server, and it will check if there are any pods which are not able to schedule because of no resources available. The node autoscaler will talk to the API server to identify, do we have any pods which is in pending state because of no CPU, no memory. Then the node autoscaler will make a AWS API calls internally. It will make a AWS API calls internally to the auto scaling groups to update the desired numbers, desired capacity. Now, do we have this node autoscaler deployed in our cluster as of now? No. So that is what we do now. We will deploy the node autoscaler. But before deploying the node autoscaler, I need to create one IAM policy and attach that IAM policy to that worker machine's role. Because I am going to deploy the node autoscaler application in the Kubernetes. So where it will run, guys? The node autoscaler application, where it will run? I am going to deploy as a pod. Again, where it will run? It will run in the Kubernetes nodes only, worker nodes only. So does that node autoscaler application, does it requires AWS permissions also to talk to the AWS autoscaling groups to increase the capacity, decrease the capacity? Your node autoscaler, you are running as a pod. That pod will be deployed in the Kubernetes node. Does that pod requires permissions? Does that application requires AWS permissions also to talk to the AWS autoscaling groups to increase the desired capacity, decrease the desired capacity? Yes. Then how can I give that permissions to that pod? AWS permissions. So that is running as a pod in your server, your Kubernetes node. If that node has a IAM role, that role has a policies for auto scaling, will it able to communicate with AWS? Because that pod is running in the Kubernetes AWS node only. If that node has a permissions, it will be able to manage AWS resources also. Without creating this IAM policy, without attaching this IAM policy to the IAM role that is used in the EKS node group, even though I have this cluster autoscaler application deployed, will it able to increase and decrease the servers? Because if it doesn't have AWS permissions, does AWS allows to modify the autoscaling group values? No. So that's why first we will create a IAM policy with this one. If you see what are these permissions, for which service we are giving permissions, if you see all are this action, auto scaling groups. We are giving permissions to set the desired capacity. We are giving permissions to terminate instances in auto scaling group, because if you don't need lot of nodes, it has to terminate additional servers. So we are giving all the permissions here. So let me create one IAM policy in our AWS. Go to IAM. Go to the policies. I will create first. I will create a policy first. I'll create a policy first. So this one, go to create policy. Go to this create policy, right? You can create using JSON directly. This one, go to create policy, select this JSON. I am going to share this one, right? Create this IAM policy. Give some name, EKS auto scale policy, something like this. Give some name. Now this policy I will attach to one IAM role. If you remember, while creating a node group, did we also created IAM role for that nodes, where we have attached the ECR read-only permission, CNI permissions? If you remember, while creating a node group, did we created one IAM role already? If you have a doubt, go and check here. Go to the EKS. Go to the EKS. Go to this compute. This is my worker group. Here, this role we attached, right? So this policy, whatever policy I created, if I attach that policy also to this role, right, it will work. So I'll go to this role, IAM role, whatever role we used in the node group, worker group, I'll attach that policy, that EKS cluster autoscaler policy. This just now we created, right? This policy, EKS cluster autoscaler policy. This one we created, right? Select that one, attach the policy. Now I will deploy the cluster autoscaler application as a Kubernetes pod. So now, while creating a cluster autoscaler, we are creating a permissions for AWS resources, because does that cluster autoscaler need to talk to the Kubernetes APIs to check whether how many parts are running? Is there any parts which are in pending state? So does it require Kubernetes permissions also, that cluster autoscaler, along with AWS permissions? So it is required AWS permissions to talk to the AWS auto scaling group, and it is required Kubernetes permissions to talk to the Kubernetes APIs to check how many parts are there, how many are in pending state. So how can we give the permissions in Kubernetes for Kubernetes resources using RBAC, role-based access control. So we are creating a service account for Kubernetes, role in the Kubernetes with these permissions. We are attaching that role, that service account. We are attaching that service account to this deployment, this cluster autoscaler deployment, so that it will give the permissions. Now, is it our own image, this cluster autoscaler? We are deploying this cluster autoscaler as a deployment, as a pod. Is it our own image? Is it our application image? It's a Kubernetes image. It's a Kubernetes image. There is a code inside that image. It will make a AWS APIs. It will call AWS APIs to increase and decrease the auto scaling groups. Now let me take this one and let me deploy. But before deploying, make sure you have give your cluster name, whatever name you have given here, and the region name. You update this YML here. Give whatever the cluster name you created, and here the region, in which region the cluster is created. So as of now, what is my cluster name? What is my cluster name? Whatever I created, EKS underscore cluster. This is the name. So here I'll just update that name. And also, in which region I have created this one as of now? The cluster is running in which region? Mumbai region. So what is Mumbai region? AP South 1. If you see here, Mumbai, AP South 1. So with this, I'll create a, till here. I'll deploy the application cluster autoscaler. Now let me apply. Now I have a cluster autoscaler deployed as a pod. In which namespace it will be deployed? Cube system. It requires very less memory, less CPU. It is able to accommodate. It is able to schedule this one because it requires very less CPU, very less memory. If you see, it requires just 100 millicore. Suppose while deploying, if this much CPU is also not available in the cluster, will this pod also will be deployed? If this much CPU, this much memory is also not available again? No. Now cluster autoscaler is deployed. Now I have few pods which is in pending state. Now this cluster autoscaler will talk to the Kubernetes API and it will check, do you have any pods which are in pending state? Let's see the logs. Let's see the logs of this cluster autoscaler now. This is in Kube system. Now if you see, is it already identified? There are some parts which are in pending state. I am checking the logs of the cluster autoscaler. There is a code in the background. Do you see it has identified these two are unschedulable, these two parts are unschedulable? Do you see in the logs, cluster autoscaler pod logs? And also what it is saying? Upcoming one node. So it is talking to the AWS auto scaling in the background. If I go to the AWS auto scaling groups, if I go to the AWS auto scaling group, now if you see here, the K8S auto scaling group, who updated this desired number? Earlier it was only 2. Now who updated the desired number? Programmatically, who had made the calls, API calls to the AWS to update the desired number? That is done by your cluster autoscaler, that application. Now, since it has updated the desired number, does AWS autoscaling will match the current numbers with the desired numbers, the current instances with the desired instances? Now, can I see one more node here instead of 2 nodes? Now, do I have a 3 nodes? Do you see? 117 seconds ago, age 117. Do I see one more node in my cluster? Since I got one more node to the cluster, does API server, I mean to say, does the scheduler will be able to schedule the whatever parts which is in pending state to that new node? Now, do you see those 2 nodes, whatever is in pending state, these 2? Do you see, is it up and running now? If you see, in that new node, this one, 5867, these 2 nodes, these 2 parts, do you see these 2 parts got scheduled in that new node? And again, if we are keep deploying the application, again, if the cluster is running out of CPU and memory, again, will it able to scale to another node automatically now? Whether you are scaling manually, whether you are scaling automatically using pod autoscaler, whether you are scaling your pods automatically using pod autoscaler, whether you are scaling your pods manually, that doesn't matter. Whenever your pods are not schedulable because of no resources available, will I get a one more node automatically? But how many nodes maximum I can get in this cluster? Again, if you see, again, one pod is in pending state. One pod is in pending state. This one, this is in pending state. Now, again, cluster autoscaler. That cluster autoscaler will identify that there is one pod which is in pending state. If I see the logs again, that cluster autoscaler pod logs, which is in kube system namespace. Now again, if you see, it is calculating internally. Now again, if you see, it is saying this node, one pod is unschedulable. One pod is unschedulable. This one, this is unschedulable. If you see, this pod is unschedulable. And again, it is saying upcoming one node. Now will I get a fourth node? Again, automatically. Now do you see, it is already created. It will be in ready sometime. It will be in ready sometime, ready state in some time. Once it is ready, will that pending part will be scheduled in that new node by the scheduler? Whatever this is in pending state, will it be scheduled in this new node? This one. You see, again, container is getting created. It is able to schedule. But will it go beyond 5? Will it go beyond 5? No, because that is your maximum capacity you have given in the node group. But if you update your node group with 10 servers, 15 servers, then will it go beyond 5? If it is maximum is more than 5, it will go beyond 5 also. That is how cluster autoscaler works. That is how cluster autoscaler works, right? So here, cluster autoscaler is running as an application in our cluster that will be bridge between the Kubernetes and AWS. The cluster autoscaler will talk to the API server to get the Kubernetes details, and it will make a AWS API calls internally to increase and decrease the desired number of servers of your node group. So it will scale up, scale down the servers based on the load. And also, since these servers are managed by AWS auto scaling group, if something goes wrong with this server, will I get a server automatically? If something goes wrong with these servers, these are the servers, right? If something goes wrong with any server, will I get a server automatically? If I intentionally stop, intentionally terminate also, I'll get another server. That is because these servers are managed by basically in the background auto scaling group, AWS auto scaling group. Now, can I achieve, I mean to say, will this EKS cluster, will this Kubernetes cluster will be highly available, scalable? If I go for this managed ones, yes. And also we can integrate with other AWS services. Now, am I getting load balancer? If I create a service of type load balancer, yes. Not only this, by default, if you see, by default, do I have a storage class in this cluster? Do I have a storage class configured by default? Did I created any storage class myself? So dynamic volume, storage class is nothing but a dynamic volumes. So whenever I create just a PVC volume claim, if there is no volume available, will I get a volume automatically, persistent volume? What type of storage I'll get? What is the provisioner it is using by default? What type of volume I'll get? EBS. EBS. Okay. This is how it works. Is everyone clear, guys? What is pod autoscaler? What is node autoscaler? Pod autoscaler will scale the pods provided you have enough CPU and memory. Node autoscaler will scale the nodes. Pod autoscaler can I use in a self-managed Kubernetes cluster also? That pod autoscaler concept in self-managed also we will be able to scale. But the node autoscaler in self-managed Kubernetes cluster, if you something goes wrong with your node, or you want to scale your nodes, will you be able to do that in the self-managed automatically? No. That is how it works. Now let's try to understand ingress, Kubernetes ingress. Did you guys went through the video? I mean to say, I have shared one YouTube link. Did anyone went through that video, like to understand what is ingress, what is the basic idea behind the ingress? Last class, I asked you to go through one video. So what is ingress? Why do you need ingress? So let me tell you this. I think most of the guys didn't went through that video. Now, when we deploy the applications in a Kubernetes, if the end user want to access the applications, will they able to access using directly, I mean to say node IP and node ports in the real time? Because if your nodes are running in a private subnets and also your nodes are keep on getting changed and end users will never use IPs and ports. So how the end user request should go to the load, our Kubernetes pod? In the interview also they'll ask. In the interview also they'll ask, can you explain the moment the user enters one URL in the browser, how it will reach your Kubernetes pod? So do we need a load balancer in front of our Kubernetes servers? External load balancer, not internal. So the request goes to the load balancer. Load balancer should route the traffic to your nodes and pods. So we have a load balancer. But if I deploy microservice applications, if I try to deploy my microservices, if I deploy 10 microservices, if I want to access those 10 services, 10 microservices, do I need to create a services, 10 services for each application? Do I need to create a service also along with the deployments? But if I want to access those 10 services, for each service, if I create a service of type load balancer, how many load balancers I will be having? For each application I want to access, each application I want to access outside. Then do I need to create a service of type load balancer for each application? In that case, we will end up having lot of load balancers. Right? Let me show you. To access this application, I created a service. Now let me scale down these parts, guys. I don't need these many parts now. Or let it be, I'll delete this later. Now I'm going to deploy one more application. I'm going to deploy one more application. Maybe I'll just, instead of typing, I'll just copy paste. Maybe let me deploy one more different application. Let me do this. So I'm going to deploy one more application, different application. I'm deploying different application. App or application, whatever image you have in your registry. Maven-web application. Okay, tag is one. Maven-web application. I'm giving tag that one. Now I'm deploying this one. To access this one also from outside, do I need to create a service to access this application? If I want to access outside, I need a load balancer, because node port we should not be used for the end users. Now, will I end up getting one more load balancer? So will it create a one more load balancer for this application, external load balancer? Now, if you see, I'm deploying this one. You see, you'll get a one more load balancer. Now you see, the parts are coming for this application. I just created a deployment. With two replicas. Parts are getting. And if you this service, do you see service also? I got a service also. Again, I got another load balancer to access this application. To access this application, I am getting a one more load balancer, since I have created a service of type load balancer. From outside, I can use this load balancer, but internally, if this pod, if this Java web application needs to talk to this Maven web application, internally, what they can use? Do they need to use this external IP address for internal communication? Or do they need to use node IP or node port? Or they can use this service name, service names for internal communication. Just service name is enough if this application want to talk to this application. This external IPs is for whom? If someone who wants to access outside of the Kubernetes from external, the end users. Can the end users access via this load balancers or any other applications which is outside of this cluster? If they want to access, will they able to use this one? Yes. Now, if I go and see in the AWS load balancers again, I am getting a one more load balancer. If you see, I got a one more load balancer. Now, if you see, this load balancer is also talking to the Kubernetes machines. As of now, how many Kubernetes machines I have? How many nodes I have? As of now, 4 nodes. Now all the 4 nodes are listed here, and it is pointing to these nodes on this port number. If someone access via this load balancer, request goes to the Kubernetes machines on this port. So on that port, what is running? That 30997. This Maven web application service is created. So request goes to the load balancer. If someone access via this load balancer, request goes to the load balancer on port 80. It will route the traffic to Kubernetes nodes, node IPs and node port. Request goes to the Kubernetes nodes, something like this, with the load balancer, right? If someone access via load balancer, request goes to load balancer, external load balancer, then that node IP and node port. Request goes to that node IP and node port, then Kubernetes service, then service to the pod. Now I have created a one more load balancer service for this application. This is my application context. This is my application context. This is my application context. Now, do you see, am I getting the response via that load balancer? Now we have two load balancers. But if you have a lot of microservices, each microservice you want to access from outside, you'll end up creating a lot of load balancers. I don't want lot of load balancers for my cluster, my Kubernetes. my applications. With single load balancer, I should be able to route the traffic to different services within Kubernetes. With single load balancer, I want to route the traffic to different applications within Kubernetes service, to different services in the Kubernetes. So that is where ingress comes into picture, guys. That is where ingress comes into picture, Kubernetes ingress. We have a ingress, one concept called ingress, Kubernetes ingress here. Kubernetes ingress. Kubernetes ingress is a resource to add the rules for routing traffic. With Kubernetes ingress, we can add the rules for routing the traffic from external sources to the services in the Kubernetes cluster. Kubernetes ingress is a resource using which we can add the rules, Kubernetes routing rules. So all the external traffic will come to the only one application that will decide to which service it has to route the traffic based on the rules. So there are two things, guys. When we deploy ingress, right, there are two components. Let's understand this diagram. Now, all the external requests will come to only one load balancer. That load balancer will route the traffic to, there is a one more application we are going to deploy, that ingress. In ingress, you have two things. In ingress, you have two things, two concepts. Ingress controller, and ingress, basically rules. So if you understand this one, this diagram, all the external traffic comes to the load balancer. All the external traffic comes to the load balancer. That load balancer will route the traffic to the ingress controller. One application again. That ingress controller will use the rules, ingress rules, whatever rules we are going to define. All the external traffic comes to the one ingress application, ingress controller, one application again. That ingress controller will use the ingress rules which we have defined. Based on the rules, it will route the traffic to the Kubernetes services like Java Web App Service or Maven Web App Service or other service, then service to the pods. So you don't need multiple load balancers. With single load balancer, with the help of ingress, you can do the routing within Kubernetes cluster to different services. We will define the rules in the ingress. So what type of rules, what type of routing this ingress supports? This ingress controller, whatever ingress controller we deployed, we are going to deploy in the cluster, right? This ingress controller, that is again a layer 7 load balancing. That is again a layer 7 load balancer internally. So what type of routing we can define if I am using ingress? If it is a layer 7, what type of routing it will support, guys? We discussed what is layer 7, what is layer 4. This Nginx, basically this ingress controller is nothing but kind of a load balancing feature, proxy service, load balancing proxy, reverse proxy. So we can define host based routing or path based routing. Right? So we have a concept called ingress, Kubernetes ingress. Very important and widely asked interview question. What is Kubernetes ingress? Now ingress, Kubernetes ingress. If you see, ingress is again Kubernetes resource. Now if you see, end user will access via load balancer. That load balancer will point to your Kubernetes ingress controller. In the ingress controller, it will use the rules, routing rules. Then it will decide to which Kubernetes service it has to route the traffic. So ingress exposes routes from outside cluster to the services within the Kubernetes cluster. So traffic is controlled by the rules. We can control the traffic by the rules defined in the ingress resource. So now ingress has two things. We can define the rules something like this. If this is the path of the application, route the traffic to this Kubernetes service. Right? Host-based routing, path-based routing we can do. As I told, there are two things in the ingress. What are the two components of ingress? Ingress controller and ingress, just ingress, that is ingress rule. So now instead of having two different load balancers for to access those two applications, with the help of ingress, with single load balancer, I can route the traffic to the Kubernetes services. For making our students' life simple, I have created one separate repository to understand the ingress and to deploy the ingress. One separate repository with the instructions here in our Mithun Technologies GitHub. I defined one repository where I'm explaining what is ingress and how to deploy that also. As I told, there are two components in the ingress. Kubernetes ingress is a resource that will allow you to configure HTTP load balancers. You can do the routing based on the host of the application, based on the path of the application to the Kubernetes services. So we have two things, ingress controller and rule. Ingress controller is an application that is basically a proxy application, reverse proxy, load balancing application. The ingress controller is an application that runs in a cluster and it will configure the load balancer according to the ingress rules. So we can deploy a ingress controller and we can define the rules. So based on the rules, that ingress controller will route the traffic. Now there are different ingress controllers available in the market. There are different ingress controllers available in the market. So what are those, right? Ingress controllers, right? We have a lot of ingress controllers. I can use Nginx ingress controller or HA proxy ingress controller, or I can go for Terrafic, this one, Terrafic we call it. Or I can go for a HA proxy or Google ingress controller, or there is a one more thing component called Istio. Istio, it is not just a ingress concept, it is not just ingress controller, it is more than ingress controller. This we call it as a service mesh. Okay. It is like ingress controller plus some additional features. Plus some additional features. So I can go for an Nginx ingress controller, or I can go for a HA proxy ingress controller, I can go for a Terrafic, or I can go for a Istio ingress. Istio is not just ingress, it is more than that. It's a service mesh. So when you get a time, just read about what is service mesh, what is service mesh, and what is Istio. I just recommend you to read something so that you can understand. It is not just a ingress controller, it is more than that. Istio. So these are the implementations of ingress controller. I can go for an Nginx ingress controller, or I can go for a HA proxy, I can go for a Istio, or I can go for a Terrafic, right? All does the same thing. So it will it will do the routing to the Kubernetes services. It will do the routing to the Kubernetes services based on the rules we are going to define, ingress rules. What type of rules we can define in the ingress? What type of routing it will support? Host based routing and path based routing. Now when I am using ingress, do I need to create a service of type load balancers for these applications, our actual Kubernetes applications? If I am going to use ingress, do I need to create a service of type load balancer for these applications? Not required, because request should go via ingress. So ingress also will be running as a controller, as a pod. So external people will talk to the load balancer. That load balancer will talk to the ingress pods, not your application pods, your ingress pods. So we need a load balancer only for ingress pods, but ingress pods will route the traffic to our actual pods based on the ingress rules. So since this ingress also running as a pods, will this ingress pods will be able to route the traffic to our actual pods using cluster IP service itself? Do we need to create a service of type node port? Do I need to create a service of type load balancer for our actual applications, for our actual pods, if we are using ingress to access? Ingress, right? Incoming request will always go to that ingress pods. That will decide where to route the traffic based on the rules. So now we have a lot of ingress controllers available in the market, as I told: Istio, Nginx, HA proxy, Terrafic, right? I will be demonstrating ingress with Nginx ingress controller. I will be demonstrating ingress with Nginx ingress controller. So we are going to deploy one application again. Like as a deployment or as a daemon set, you can deploy. I am trying to deploy Nginx ingress controller. If you see, I am deploying this image. This is your controller, ingress controller. I am going to deploy this as a daemon set, or I am going to deploy this as a deployment. Whatever you want to deploy, you can do this. This is your ingress controller. I am going to deploy. So all the external traffic has to go via ingress. In that case, do I need to create a service for ingress controller pods? All the requests should go via ingress pods only. Since all the external user has to go through the ingress controller pods, what type of service is required for ingress? Only for ingress pods. What type of service is required? The load balancer service, only for ingress. So I will be deploying this ingress controller using these YML files. as a deployment or as a daemon set I will deploy. And also we are going to create namespace service account because I want to separate this ingress into a separate namespace. Suppose I don't want to deploy this ingress related pod services in a default namespace or your applications specific namespaces. In that case, I can create a separate namespace. I'm creating a separate namespace and I'm creating a service account because the that ingress controller pods, does it require access to the APIs, Kubernetes APIs, like how many services are there? Does it require permissions to the Kubernetes services to see how many services are there, where it has to route the traffic? So we are giving a permissions with the help of service account and role. We are giving permissions to the services, these services, these permissions to the services and endpoints. And we are giving permissions to the config maps, secrets, pods, whatever it is required, the rules, ingress rules. We are going to define the rules, ingress object we are going to create. Does your ingress controller require permissions to read that rules? So we are giving all the permissions, here. So we will be deploying the ingress using all these YML files. So we can deploy directly from their GitHub, but to make our students, life easy, I have documented very well in our own GitHub, right? If you see here, they have given the link, right? How to deploy all those stuff. But it will be very difficult for you. So there is their own GitHub. They have their own GitHub, right? So they have given how to deploy that ingress controller. They have given the YMLs. Just I have splitted that YML into multiple YMLs to understand more easily. Okay. So this is official Nginx ingress controller documentation. So now let's follow these instructions. I have all the YMLs here. I have given the installation instructions. So let me clone this into one server where I have a kubectl installed. So here I have a Kubernetes client. Here I am going to clone that. So Git software is not there. Let me download Git software. Now let me clone this. Now let me go inside that whatever folder I have, and inside that folder deployments folder. Inside this ingress folder, I have a one more folder called deployments. I'll go inside that. So we'll try to create whatever is required to deploy the ingress. Nginx ingress controller I am deploying. I am creating a service account and namespace. Now we got a namespace. Nginx ingress namespace. In that namespace, I will deploy the ingress related objects. So here we are creating something like a role binding, all those things. So we deployed whatever is required. Then we can deploy the ingress controller. There are two options. One as deployment or another one as daemon set. Whatever way you want to deploy, you can deploy. If I use daemon set, right, how many parts will be created for that ingress controller? If I use daemon set, only one part. Each node will have one pod. Suppose if I have 4 nodes, how many ingress controller pods will be created? So if I just create a ingress pod with single replica, if I just have a one pod, all the cluster, all the external traffic go via ingress controller. If there is a problem with your ingress controller, if all the requests are going via ingress controller, if you have any issue with your ingress pod, if you just have one pod, will you be able to access the applications externally? Whatever applications which are running in that cluster, if there is an issue with your ingress pod, so you better deploy as a deployment with more replicas. You better deploy your ingress controller as a deployment with more replicas, or you deploy it as a daemon set, whatever it is. If I use daemon set, I can use daemon set or I can use deployment, but it will have a more replicas. Now, if I have a daemon set deployed, if I'm creating as a daemon set, how many parts will be created? Based on how many nodes you have in the cluster. Now I am deploying the daemon set. Now I have 4 nodes. Each node will have a ingress controller pod. If you see where these are getting created, I don't see that ingress related stuff in this default namespace. I don't see a ingress controller pods. In which namespace it is getting created? We created a separate namespace, right? Now do you see? Now I have a ingress pods running in this as a daemon set in this namespace. Now all the end users traffic has to go via this ingress pods. So in that case, do I need a load balancer for this ingress? Do I need a load balancer for this ingress pods? Because external traffic should go via ingress, right? External traffic should go via ingress pods. So to access these ingress pods from outside, we will be creating a load balancer only for ingress now. So you deploy load balancer service for ingress. This one. Now I got a load balancer. Now I got a load balancer. So this is pointing to the ingress pods. Now I don't need a load balancers for other applications, right? For this Java web app service, I don't need a load balancer. Maven web app service, I don't need a load balancer. Now I will route to these services with the help of ingress controller and ingress rules. So I will delete. Guys, you already have a load balancer. Can I change this load balancer to the node port or cluster IP? Can I degrade? No, you will get an error. I can't change. I can delete and recreate. I can delete and recreate. What I will do, I will delete these services because I don't want a load balancers. External load balancer. I will delete this service as well as this service. Now, since I am deleting a service of type load balancer, will the load balancers also will be deleted in your cloud? Those two, these two, this one and this one. If I refresh here, those two will be deleted. It is deleted. Now I have one load balancer. Now this is pointing to which one? This is pointing to which one? Now I have one load balancer. It is listening on these ports, the load balancer. It is routing the traffic to these ports. Basically, this load balancer is now pointing to which application in our Kubernetes? That is pointing to the ingress, only ingress pods, that ingress controller pods. Now I will change that services. I will change that services. I don't need a load balancer now. I want to route via ingress. Now I will change this from load balancer to the cluster IP. Cluster IP is sufficient for us. Let me change for both, and later I will apply. I'll change to the cluster IP. I'll apply. Now I just have a service of type cluster IP. Just a service of type cluster IP. Now to access this one from outside, I can access via ingress controller by defining what? By defining what? By defining the rules. What is the next one? Ingress rules. We have a rules. What type of rules it will support? As I told, if you see, we have a ingress controller. We need to define the rules. So based on these rules, this guy will route the traffic to your pods, your actual Kubernetes services, your application services. What type of rules this ingress supports? As I told, it supports host-based routing or path-based routing. Now we need to create a rules, ingress rules. Ingress rules. So host-based routing, something like this. You define the rule. I'm just demonstrating host-based routing. Host-based routing. Suppose if someone is accessing something like this, Java web app dot mithuntech devops dot co dot in. If someone is accessing something like this is your ingress rule. You are defining the rules. Okay. So if someone is accessing something like this host, this is the host to which Kubernetes service you want to route the traffic. The service name, Kubernetes service name. If someone is accessing something like this, if I want my ingress to route the traffic to this service, Kubernetes service, I can give this name, service name. I want, if someone is trying to access this host, I want my ingress to route the traffic to these pods. I will use this service name. Is this service is pointing to these pods? Right. So I will use this service name. Now, whenever request comes to the ingress, based on this rule, if someone is accessing this domain, if the request comes to the ingress, to which Kubernetes backend, to which Kubernetes service it will route the traffic now? To this Java web app service. No, that service will route the traffic to the respective pods. And what is the service port? On which port you created service port? Not the target port, not the node port. On which port service is created? 80. So that's service port. If someone else is accessing this domain, Mithun Tech, sorry, not Mithun Tech, Maven web app dot Mithun Tech DevOps dot co.in. So, to which service you want to route the traffic? I want to route the traffic to this service. So, this is what type of routing? What type of routing we are defining in the ingress rules? This is what type of routing? Host based, not path based, Vijay. This is host, right? The host itself is different. Here, Java web app.mithuntechdevops.com.co.in, this Maven. But before that, do I need to map all these domains with my Nginx load balancer, that ingress load balancer? You can use regex also. You can use regex also. It supports like star. Not, you will have a regex at the prefix, not the suffix. Prefix should be regex, not the suffix. Okay. So, but before that, do I need to map all these domains with my load balancer in the DNS? Otherwise, will it be able to resolve to which it, where it has to route the traffic? Suppose without mapping these domains in the DNS records, if I, some end users try to access something like this, Java web app.mithuntechdevops.co.in, will it able to resolve to the IP if you don't do the mapping, DNS mapping? If you don't have a domain, how can you practice this? If you want to practice, this, how can you practice if you don't have a domain? You don't purchase the domain. You can use your host files. I think while local system host files, your laptop host files. I think I have explained this one in the AWS also, right? If you don't have a domain, you map this some names with the IP. To which IP now I need to map? Now I have to map to which IP? To this load balancer, whatever load balancer you got for an ingress. Whatever load balancer you got for an ingress, you map with that load balancer. But I have a load balancer, I have a domain also. So this, I will map all the domains with my this load balancer. I'll go to Route 53. I'll go to Route 53. I already have a hosted zone. Now I will point all the IPs, I mean to say all the domains, whatever I want to do, this one, and all this one, to that load balancer. I will edit this because I created for a different purpose. Now, if someone is accessing something like this, Java web app.mithuntechdevops.co.in, I will point to that load balancer. So which load balancer I will point? I have a classic load balancer created. In which region? Mumbai region. The load balancer. So this one, second one, this is created for a different purpose. This is the load balancer which is pointing to the Kubernetes ingress. Similarly, this one also, I'll map to that. Now, whenever someone access this domain in their systems, what is the flow? Guys, this is very important. In the interview also they'll ask, if the end user access some URL in his browser, how it will reach the Kubernetes pod? First, what will happen, guys, from the end user system? First, what will happen? DNS lookup. First DNS lookup. For what purpose it will do the DNS lookup? Request goes to the whatever DNS servers configured for that ISP, that network provider. For what purpose it will happen? DNS lookup to resolve IP of the domain. Now, I mapped in my AWS, I mapped this domain with my load balancer. So if anyone access this domain, to which IP it will resolve? To my load balancer IP, that ingress load balancer IP. Then request goes to, once it is resolved to the IP, then request goes to that IP. Goes to IP. Now that IP is nothing but load balancer IP, which is mapped to the domain. That load balancer, external load balancer, return request goes to the load balancer. Do we have a ELB, external load balancer now? DNS lookup, once the DNS lookup happens, then request goes to the load balancer. Now I am using ingress, right? The load balancer will route the traffic to, if I am using ingress, will it directly route the traffic to your pods, or request goes to the ingress? If I am using ingress, if you are using ingress, it will go to the ingress pods, then ingress will do the routing. If I am not using ingress, then it will directly talk to the your pods, right? Then request goes to the domain load balancer. That load balancer will route the traffic to node IP and node port. Node port of what? Node port of ingress service. Then request goes to the ingress controller pods. Ingress controller pods. Then ingress controller routes the traffic to the services based on the rules. Right? This is how it works. Right? Sometimes in the interview they'll ask. So you explain this diagram. First DNS lookup. DNS lookup to resolve the IP address of that domain. First DNS lookup, then load balancer. Once it resolve the IP of the load balancer, request goes to the load balancer. That load balancer will route the traffic to your controller, ingress controller pods. That ingress controller pods will use the rules, whatever rules you have defined. Then based on the rules, it will route the traffic to respective services. Now I have mapped all my domains. Now let me access something like this. Why I am getting 404? What is missing? Why I am getting 404? What is missing? I mapped all these domains to my ingress controller, that load balancer. Request is going to load balancer. Load balancer is routing the traffic to ingress pods. But did I define the rules, guys? Where to route the traffic, how to route the traffic? Did I created a rules in the cluster, that ingress rules? If you see, If you see, the request is going to these parts. If you see the logs, you can see. You can see request is going there, but 404. Why it is 404? Request is going to that ingress parts. Why it is 404? Because did we define the rules? Ingress rules? No, right? That's why we are getting a 404. Ingress controller, that is saying 404, because you have not defined the rules. Now, if I create these ingress rules, now will it able to route the traffic to the respective services? If this is the host, it will route the traffic to this one. If this is the host, then it will route the traffic to this one. Now let me create a rules. The file name can be anything. As of now, I don't have any ingress rules, right? So let me deploy this ingress rules. Now I have a ingress rules. Now I have a ingress rules created. Kubernetes ingress rules. Now this Nginx ingress controller will use these rules to route the traffic. Now do you see, am I getting a response? Request is going to ingress. Ingress is routing the traffic to the respective services. Now do you see, this application is running as a pod. This application is running as a pod. I am able to access. I customize this application. It is printing the IP address from where it is serving. If you see this IP, so if you see that IP, this 192.68.96.113, 96.113. Do you see? Now I am accessing using domain. Is it routing the traffic to this application which is running as a pod? This is the pod IP. Now I am using the domain. Request is going to the load balancer. That load balancer is talking to the ingress controller. Ingress controller is using the rules to route the traffic. If I use Kubernetes ingress, will I have a complete control on the routing within my Kubernetes by defining, by updating the ingress rules, by deleting the ingress rules? Can I control the traffic within my Kubernetes, where to route, how to route? So ingress controller is used to control the routing to your Kubernetes services. Based on the rules, it can route the traffic to the different services within your Kubernetes. In that case, if I have hundreds of applications, do I need hundreds of load balancers, external load balancers, or just one load balancer is sufficient to route the traffic to different services? Based on the rules, only one load balancer is sufficient. So in the real time, we are going to use ingress. Real time, you are going to use ingress. Someone might be using ingress with Nginx ingress controller. Someone might be using ingress with HA proxy ingress controller or Istio. But the concept remains same. You have a rules. Based on the rules, it will route the traffic. So this is host based routing. Similarly, there is a path based routing, right? Host is same, but path is different. In that case, I can define the path based routing. That I will continue tomorrow, guys. Okay. Tomorrow, first 10-15 minutes, I'll again discuss about ingress only. After that, I'll start RBAC. RBAC, role based access control. Right? So tomorrow we'll continue. That's it for today. Right? If you don't have a domain, you map these domains in your local, in your Windows system host file. You map this domain with IP address. Which IP you need to map? If you don't have a domain, don't do in the Route 53. You can do it with your host file, within your host file. Load balancer IP, you map with load balancer IP. Which load balancer IP? Whatever load balancer is created for your ingress. Whatever load balancer is created for your ingress. How can you get the IP address of that load balancer? What command you can use? You use ns lookup on that load balancer name. It will return the IP. So you go through this video, guys. In this video, in detail, I have explained how to do it if you don't have a domain. In our YouTube channel, already we have whatever I discussed. Whatever I discussed today, it is already there. This Kubernetes ingress. This video, Kubernetes ingress. You go through this video, right? Same thing, whatever I discussed today, ingress, right? It is part of this video. Okay, guys, that's it for today. We'll continue tomorrow with RBAC. Okay. Thank you. I'm stopping the session for today. We'll continue tomorrow.